Hello everybody and welcome to this webinar. My name is Lee Snyder, the product manager here at Trimble, and I'm excited to be hosting this partner spotlight for one of our partners, Qnect. If you're not familiar with Qnect, what they've done is they've developed an innovative approach to both connection design and cost optimization, which you'll be able to see here in this presentation specifically for your still projects. So this is something that they've been working on for quite a while, and it's very, very impressive. I think you'll be pleased with what you see here. So in a few minutes, I'll just hand this over to the Qnect team, but I just wanted to go through a few practicalities before we begin. If you haven't done a webinar with us before, you have the ability to put in any questions there into the question window. It's in the user interface for the GoToWebinar app that you should see there on your screen. Feel free to send us any questions that you have, and we'll have a Q&A session at the end to be able to answer those. And then if there are questions that we're not able to answer due to time or whatever the case may be, we'll reach out to you after the webinar, either by email or by phone, to ensure that we answer those questions for you. We'll also be recording this webinar today, and we'll send out the recording so that you can review it again if need be, or so that you can share it with your colleagues as you would like. So that's enough for me. I'm going to go ahead and introduce our main presenter today. His name is Jeff Haustor with Qnect. He's one of the co-founders and the CEO of the organization. So Jeff, I'll turn the time over to you, and feel free to take it away.
Hi, thanks Lee, and thank you to Trimble for giving us this opportunity to do a webinar. I'd like to thank everyone also for taking the time to see what we have to offer. So I'll just jump right into the presentation here. As Lee was defining, Qnect is a service that is based on your preferences. We design and engineer, we engineer every connection and put it into the Tekla model directly. So we're giving you the ability to do this many times and do optimizations so you save time and money while we bridge the gap between engineering, detailing, and fabrication. Why you should use Qnect and Tekla? This is where you are going to save time and save money between the two products. So today's agenda, I'm going to do a live demo, and I'm going to show you how you're saving time and where the $100 per ton comes from. I'm going to explain the optimization group of products that we have, the bolt optimization, preference optimization, and doubler optimization. I will then show you the reports so you can compare the costs and also what gets PE stamped, showing all of the engineering required. And then I will discuss how you can get involved and taking the QuickQnect challenge, and then we'll go into some questions and answers. So I'm going to go right back to the model right now and show you the live demo. Here is a model. This is in version 2016 of Tekla. We also work with version 18, 19, 20, 21, and 2016i will be out soon. This is actually a model that Qnect is being used on. It is a 3,700 ton medical center. The number of connections that we were able to do on this building was 4,400 connections, and we were able to deliver that in 37 minutes. We were able to also offer savings of $324,000, and that comes to about $88 per ton. So here you can see that I ran it. You can see all these blue ticks are the welds associated with it. I'm just going to zoom in so you can just see a couple of the connections that we did, no matter the type, beam to beam, beam to column web, beam to column flange. I can go into some more detail across the entire building. You can see that it's almost all skewed. Let's see, I could show that we have some shear plates. I have a knife connection here where you would see both sides. We do all the coping. We show the welds. We show all the bolts. And now I'm just going to show you how you actually use our tool. So let me just scroll over here to another connection area that we haven't done yet. And here's a good spot. It has a bunch of different types. And the way our product works, and that you would do, is you just highlight the section that you actually want to run. Now, the first thing that you need to do in order to get us working with Tekla is you would go to our website and you would click on the download button. It would download some software that runs on top of Tekla, and basically what it does is it just adds 3 buttons, button 1, 2, and 3. Now, I've highlighted a section. Now this, you would either be highlighting a floor, a phase, or an entire building, actually, if you want to do estimating prior to winning the job. And then you press button number 1. This will bring up our login for our cloud service and allow you to run those particular connections, and it securely goes up. And I will just call this particular session Tekla Connect. It will export the information, so you get to keep your model. The model stays in your possession. We don't take it. We just extract the geometry that we require. And then what you do is you would go in and you would look and edit these preferences of what exactly you want. It's very flexible, and it allows you to put in exactly what your requirements are. And you can see you could choose a design basis, how you want the forces put in. Of course, forces in the model would govern, but then the rest we would do not connect them or fill out the table using UDL factor based on what you put in, or 90% beam shear yield. You also can specify the connection types. So what that is the fabricator would like to use for shear only beam-to-beam connections. You could choose as many as you would like, and this is actually our preference order. You would specify exactly what you would want. We would try the first connection, and if that one wasn't able to handle the load, like if shear plate wasn't able to handle the load, we would then run the next type, like a double angle, in order to deliver exactly what you wanted. So I'm going to go back into Tekla. You then press button number 2. What that does is it actually download the engineering information, and all this time you had control over your model. We don't take it. We just grab the geometry associated with your model, and then I hit submit, and now I get all of the engineering directly downloaded into your model in a couple seconds, and it imports it directly into the model. So as you can see, I connected a few items in here. You'll see the beam connections, beam to beam, and then you'll see the beam to column flange. Here, you'll see the beam column web. We got some stabilizer plates in there, and that allows you to have a fully connected and designed model. Now the key here is, and this has never been done, you can actually click on the component, and you can see all of the engineering associated with that individual connection. So I will see all the connection conditions, like in this particular case the reaction was 230 kips, and the vertical shear says right here 245. We design each connection very efficiently. So we iterate. We start with the thinnest shear plate that you would allow us to do. Then we also start with the smallest bolts that you give us in the preferences, the smallest type of weld, and we iterate slowly up until we meet all of the requirements in AISC. You will see all the information associated with what we designed, including the stabilizer and stiffener plates. You can then drill down and see the strengths. This would be all the calculations that we did, yield, rupture, buckling. You would see all the limit states required. And then I can actually drill down even further and see in English, or kind of English, all of the details, including like, you know, what page in the AISC manual, all the details of the calcs, the bolt bearing, how that was calculated based on all the bolts. There's a lot of bolts on this one. The beam strength calcs. I see shear plate calcs, and all of the weld detail information. So now on these reports, these are the things that also you would send in, or you would have as a package that would be stamped by the connection engineer. You would have the information that would be the list of all the different specifications, all the strengths reports, and then you would show them a detail calc on any given one. Now the key with our detail calcs is it's not a sample, it's actually all of the calculations in total. So that's how the process works overall. And given that you saw how fast that was, you also have the ability to do this using for modifications that come from the EOR. These are always disruptive in everyone's process, and it takes a while to go through the connection engineer and over to the detailer. In this particular case, the EOR sends his bulletin. You just click on that within the model, and you would just change, like you would just change this particular beam, and then it would automatically ask you to re-engineer all of those connections that are affected by that change. So you won't miss any or anything like that, and it will then automatically re-engineer that calculation just like I highlighted. It functions the exact same way, and the key here is it's free. We do not charge additional money for any of those adjustments. Next thing I would want to discuss is our optimization tools. So the first optimization tool I want to show you is our bolt optimization. What I see here is a bunch of bolts, and it's using standard spacing, which is 3-inch vertical spacing on the bolts. And I see here that I have 21 bolts on this particular one. I have, what is this, 3, 6, that's 18 bolts on that one. And then on the last guy, I have 3, 6, 12 bolts on that one. Okay, so what I'm going to do, just so you can see how easy this is, like I'm going to just delete these columns, these connections. Okay, so those 3 connections are gone. I'm going to go over to the preferences, and I'm going to go to my bolt preference. Just go down to the bolt optimization. So what this says is, would you like us to take the vertical hole spacing and iterate from the traditional 3 inches up to 6 inches to achieve the fewest number of bolts in each connection? So I'm just going to hit yes. Very simple. I hit submit on our web page, and I go back to the model. I'm now going to just highlight those connections. I'm going to press button number 1, just like I did before. I can do the whole building or whatnot. I'm going to call this Tekla Connect BOP. And BOP stands for Bolt Optimization. And I hit submit. Now what I'm doing is I'm actually designing the engineering, trying every combination of every kind of connections from smallest to largest. And I'm doing it with many different types of spacing, from 3 inches all the way through 6 inches. So while we're waiting for that, which will only take a few seconds, I just wanted to show you a couple more of our information on the connection. You can specify cope clearances and minimum setbacks. Basically, you can go all the way to the point where if mandated connections come along from an engineer, you can replicate that information and actually gain all of the advantages of our speed, where on the first day of receiving the stick model, with our flexibility whether or not it's mandated connections or not mandated connections, you have the ability to instantly have all of those connections into the model itself. So let's see, what else can I show you? Some of the bolt preferences. I see that it's completed, so let me go back to the model and just show you. I'm just going to load those back in by pressing button number 2. And this only takes a couple of seconds. You choose BOP, hit submit. By the way, this is a live demo. This is actually how long it takes. So on the first day that you're running this thing, you're going to be far ahead, like 6 weeks ahead from where you would normally be. So now let's look at the details of this connection here. So this side used to be 21 bolts. So now I am down to 10. That's a more than 50% savings on the cost of this connection. The second side, I see we're down to 8, and I had started with 18. Once again, it's a dramatic drop in the number of bolts, still meeting all the requirements for AISC because we check all the states, the limit states. And the last one, I see we got down to 8, and it started with 12. Still a dramatic 30% savings. So you will start seeing how these savings add up. Now the second thing I'd like to show you guys is our preference optimization. So I'm going to just go back to our presentation here and click one more time. Now because we run so fast, picture your first day. You get the stick model, you win the job, you have the detail that does the stick model, or you do it in-house, and you run the job trying a bunch of different things. So like here you can see the top one is a shear plate job. So you try shear plate, or you try it single angle bolt to bolt, you try it double angle bolt to bolt, you try a whole bunch of different ways because it's still the first day. Now what would happen is you would have a baseline where you would have told us, or you've done it yourself, you know, we always do single angle, or for this particular job we decided to do single angle bolt to bolted because that was our guess based on all of our experience, that kind of thing. And then we ran it a bunch of different ways, or you guys going forward will be running it different ways. I'm just going to zoom in so you can actually see the numbers. So we had a baseline. And the baseline was single angle bolt to bolted, and if that didn't work, it would go to double angle bolt to bolted. And you can see we used A325, 7/8" bolts, and then 1 1/8. So first we tried 7/8, that didn't work, we go up size. And the cost associated with the cost of the physical bolts, punching the holes, doing the welds, this includes the man hours of installing it by the erector, of putting those bolts in, and just for the materials for connection design. And then we ended up getting it down to, and here you can see something weird. Normally, I would say, people do not choose 7/8 A490 to be their primary bolt throughout the building. I mean, it's weird, and but we were able to, on the first day, identify that as something that you would want to do. So now you can see that from the preference optimized where we ran it, we had 30,000 bolts that would need to be put into this building. We were able to get it down with our bolt optimization and with using our preference optimization, where we just chose a different preference and reran it down to 19,000 volts. So the cost savings is $324,000 on this particular job, which comes down to, in this job, $88 a ton. That's a lot of money, and it doesn't include all the savings associated with the smoother job being 6 weeks earlier with a connected model. This includes, so now that's our preference optimization and includes the numbers for our bolt optimization. The next area that we focused on was doublers. Now when I say doublers, I mean the beam web reinforcing plates. So whenever I say doublers for the next couple of slides, I mean beam web reinforcement plates. So here was an engineer's design. He sent it over. He told us, you know, what size beam and how many kips each one would be, and what the number of bolts. And so we put all that information into our system, and we're able to run it on the whole building. And what we saw was there's 787 doublers were required. Now this is the kind of data or information that is not available today. You would end up getting this at the end of the 6 to 8 weeks, and you wouldn't be able to do anything at that time. It was just too late. Well, here I could see the reaction that I got, but I could also, what we put on this doubler report was actually the beam capacity if I didn't use this doubler plate. So this is a Qnect report, and this was an actual Qnect job that we ran, and see that these numbers weren't great. So at this point, the EOR, well, the connection engineer actually sent it back to the EOR saying, you know, is there anything we could do about these? And as you guys know, the EOR has a couple of choices. He can reduce the load requirement for those particular, or he can increase the size of the actual beam to handle that load without the doubler. And in this particular case, the EOR actually went in and changed his design requirements so that there were no doublers required. There's a large cost associated with it, but we didn't include that here. So just so you can get a good sense for what kind of savings, and this doesn't include your time savings and the ability to get it out the door more quickly, and also the free, well, actually I think we did talk about revisions. But preference optimization, we ran a bunch of different, you know, we just looked at all of our customers' jobs that they've run previously and estimating what an average savings would be. And we see the preference optimization is offering about $43 a ton. Bolt optimization about $31 a ton. The doubler is very project dependent based on the forces and how it was designed. The connection engineer, they have a reduction in scope. They don't have to do the design of all those. What they would do is just the ones that we did not do. And we have a tool that I'll show you in a second that helps with identifying those that the connection engineer would need to focus on. The detailer would have a small reduction in scope as well, about $10 per ton. And this is just based on our previous jobs that we've worked with. And then you get a revisions savings, where is approximately $12 a ton. And the cost for QuickQnect is actually $12 per connection. It ends up somewhere around $5 to $12 a ton, depending upon the particular model. But in general, our typical savings run about $87 per ton on average. We've seen well over 100, and we've seen in the range of like 60. 70. So here's the map I was discussing a moment ago, where it helps the connection engineer when he runs the project. It actually shows all of our connection details right in the floor plan map, so he can identify the ones he needs to focus on, so that it just gets delivered just like it always does to a fabricator and to the EOR and the connection engineer. And right in it, I just zoomed in a little bit, but it actually shows you our connection code, which maps back to all the job standards and all the details in our engineering that we've delivered. This, the key is the connection engineer is now delivering 100% of the model, just like he did before. So here, the key is for a fabricator that nothing is changing. The fabricator today hires a connection engineer and a detailer. The connection engineer will have the will own the process of using Qnect. He will run the process of Qnect. He will work with us directly, and he is fully responsible for delivering these particular engineered connections, whether they're ours or not Qnects. So from a fabricator's perspective, he just can run just like he normally does, and he just gets a pile of cash at the end of the day. Connection engineers have the opportunity now to bring this optimization value to their fabricators and win more business. Detailers can now start offering the ability to do connection engineering working with a connection engineer. So if there's a tight relationship between the detailing and the fabricator and they want to continue working, they can do that. And last but not least, EORs, also we are now offering them the infrastructure for delivering 100% connected models. So basically everyone wins. So how do you get involved? And first of all, you could just call us. You can email us. You can go on our website. There's a way to download it, and it automatically notifies us. But the bottom line is we are extremely confident with our optimization services. And we want you to have the lowest cost for your projects. So you sign up for the QuickQnect Challenge at Qnect.com. You upload your model. It could be a live job that you're just estimating or something you've already estimated, and now we're just going to save you a pile of money. Or a test job, one that you just finished, anything like that. And we or one of our preferred connection engineers will send you the QuickQnect savings, just like I showed previously, for free. We'll just let it rip. We'll send it over to you, and you will see all of the data required. And if we don't save $20 per ton based on the baseline that you guys specify, then you can use QuickQnect for free on that job. You will be able to see this URL when Lee sends out the details. So the bottom line is between Tekla and Qnect, we are your competitive advantage. We can deliver optimization savings, as I've shown, and we can deliver a speed that you've never seen before, only with Qnect and Tekla. So that's all I have to say at this point, but I will certainly answer as many questions as we get to, and I send it back to Lee.
All right. Thanks, Jeff. Great presentation there. We do have a few questions that we'll go through. For anybody else that wants to continue online with us, feel free to send those in and we can answer those. So one of the first questions is, so with the connections that are applied there within the model, how do you handle the engineering of the connections for the ones that Qnect doesn't do? So maybe there's some that were omitted or something when the process was run.
Yeah, no, there'll certainly be connections that we can't handle as of yet, complicated connections. And what we do is we use our connection engineers or your connection engineers and work with them. Basically, what they will do is they will run the model just by highlighting it as we showed you before, pressing button 1 and 2. And they will then use the map tool, which I was showing before, to identify those connections that we have not done. And then they will do it the old-fashioned way. They will actually design that connection, create the charts necessary, and send it over to the detailer. So that from a fabricator's perspective, there is no change. 100% of the connections are being done.
Got it. All right. So that leads into another question that we have here, is that who's liable for these connections?
That's a great question. There is no change in the process as it exists today. It's the same as today, where the connection engineer is responsible for stamping the connections. We have connection engineers that have already evaluated our connections and are very comfortable stamping ours. And of course, they will be do PE stamping for their own connections. And you can also, if you have a particular connection engineer that we don't work with yet, just send them over to us. Basically, it allows them to offer higher-end services to their fabricators. And if they need to, they can validate our connections. So they can offer better optimized services for their fabricators.
Great. Okay. We got another question just came in. It says, can we request changes to your calculations?
You can definitely request changes to our calculations, although they've been reviewed by many connection engineering firms external to us. But what we're delivering are actually fully designed and evaluated by our QA team, engineering staff, and by external folks. But if there's something that you're interested in, you send it over to us, and we'll definitely make modifications and customizations for the folks that need it.
All right, great. And let's see here. A question, you showed before in that slide a number of times that the job was run to find kind of the best optimization. Are you seeing, I guess, how many times are these usually run before, you kind of arrive at the lowest cost?
Yeah, no, that's a good question. What we've typically seen, most of the customers are running it like 7 to 10 times, but what we see is sometimes like they'll load it into the model and they'll look at the model and they'll see like, oh, that's interesting. How is, I see that there's tons and tons of bolts in every beam to column web. So then what you do is you go in and you change the beam to column web to use double angles instead of shear plate, or whatever you want to try. Or you notice that there seems to be a lot of bolts. Let me just give one more. So it's more of an interactive thing, but typically what we're seeing is 7 to 10.
Gotcha. All right. I think we got time for one last question here. It says, can I use Qnect where the connections are mandated by the EOR?
Yes. Our software is very flexible. When you start looking at our, so you can just call us and we'll give you access to start playing around with our software, certainly. But it allows you to put in all sorts of information to actually match mandated connections. We actually had a situation where there were mandated connections. The fabricator working with the connection engineer ran it using the mandated connections, but then changed a couple things in order to make it cheaper. And between the connection engineer and the fabricator, they went back to the EOR and said, is there a way where you can change these few things? And in that case, they went back and the EOR was comfortable changing the mandated connections, and it saved the fabricator tons of money.
All right. We got actually a follow-up to one that came in before, so we'll hopefully finish that one off. So this was back to the question, can we request changes to your calculations? And they're basically saying it's not so much about whether the calcs are right or wrong, but just more about the preferences. And he's saying here, is the customization is project-based? You want to address that?
Oh yeah, every project that you do, you fill out all of the preferences. We created a nice button for you that allows you to actually do a job copy. I don't know if you can see, oh yeah, you should be able to see the screen.
Yeah.
All of this information here is actually job specific, right? So I put this in, but then I have the ability where I could just go into my preferences and just hit this copy button in order to copy all of those preferences, and then I can make it unique for that particular job. I also have the ability where I could actually have two setups, two different preferences, where the first one I'm running SharePlate, but then what I do in the model is the next bunch of floors I reduce it to switch it over to double angles, for instance, or whatever I'd like. So it allows you to run many different ways for each particular job that you want, and for every fabricator that you happen to be working with, if you're a detailer or a connection engineer. And that's how we're able to actually run it, like 17 times on that last job, where we can be very flexible on how each job is actually run. You're in total control.
All right. I got two more. Hopefully they're quick. Do you guys support the Canadian code? And does Qnect check weld sizes?
Canadian code, we're expecting in I'd say 3 months. We're currently working on getting metric up and running, and we're in QA with that right now. And then we're moving on to Canadian code. It ends up CISC and AISC are very similar, and we are able to add those additional states to make that change. So yes, we will have Canadian code available.
All right. And then the weld sizes?
Oh yeah. Oh yeah. Yeah. Of course, we iterate. We do full limit states on all AI that's in the AISC. So we always start with the minimum thickness required for every weld and iterate up slowly until we match the limit states for all the welds that are in there.
Perfect. All right. I think that's all we have that's come through so far. So if there's any others that we missed, we'll definitely reach out via email or phone call and address those. We'll go ahead and close down now. We definitely appreciate everybody's time, especially Qnect. Thank you for taking the time to present this to us. We hope you found this webinar worthwhile. Like I said, we'll send out the recording later, and please stay tuned for more future webinars from Trimble. Thanks, everybody.
Thank you all.